Welcome to The Explainer. Today, we're going to pull back the curtain on how some of the smartest AI systems are actually built. And it turns out it's less about finding one single super genius algorithm and a lot more about being a master chef. So let's open up the cookbook.
Okay, so let's just kick things off with this question. I want you to forget that whole image of a single, all-powerful AI brain, like some kind of sci-fi superintelligence. The reality? Well, it's much more like building a championship sports team, where every player has a very specific, unique skill. But, to really appreciate why that team approach is so powerful, we have to look at the problem with the individual players first. We're talking about these one-trick pony algorithms.
And this is really the heart of the problem, right? You have these algorithms that are absolute geniuses at one particular thing. I mean, they're incredibly efficient. But the real world is messy. You throw them a curveball, something they weren't expecting, and they just freeze. They get totally stuck.
Okay, let's take a classic example, the A-star search algorithm. It's famous for pathfinding. Think of it as the world's best GPS for a map that never, ever changes. It'll find you the absolute shortest, most perfect route. But what happens if there's a surprise road closure that wasn't on the map? A-star is toast. It has zero ability to improvise. It is totally rigid. So, how do you get around that? Well, this is where engineers and developers started thinking less like mathematicians and more like chefs. They figured out that the secret sauce isn't finding one single magic ingredient. It's about creating the perfect recipe. And that brings us to the core idea for today, the hybrid algorithmic framework. Now, it sounds fancy, but the concept is actually pretty simple and honestly kind of revolutionary. You just combine different algorithms. You literally mix and match them so that the strengths of one algorithm cover the weaknesses of another. And what you end up with is something way more powerful than any of its individual parts. And the process really does look like you're in the kitchen. First, you figure out what you're trying to cook. That's your real-world challenge. Then you pick your base ingredient, your main algorithm. After that, you start adding complementary flavor algorithms. And boom, you've combined them all into a brand new, super powerful solution. All right, so enough with the theory. Let's look at some of these recipes in action. And robotics is the perfect place to start, because if there's one thing robots have to deal with, it's our messy, totally unpredictable world.
So, recipe number 1. This one tackles a classic robotics headache. How do you get a bot from point A to point B when things can pop up out of nowhere?
And here's how they do it. Remember our old friend the A-star algorithm? The one that's great at planning but terrible at surprises? Well, you use that for the big picture, the best overall route. But then you mix in something called an artificial potential field. Just think of it as a real-time force field around the robot that literally pushes it away from obstacles it didn't see coming. So you get long-term planning and short-term reflexes, the best of both worlds.
Okay, that's great for following a map. But what if the robot is going in blind? What if its job is to create the map? Well, for that, you need a totally different recipe. We call this one the Smart Explorer. So for this one, the base ingredient is the RRT algorithm. It's kind of cool. It just grows out randomly, like the branches of a tree, to explore a big space really, really fast. But to make it smart, you add that same force field algorithm we just talked about. That force field acts like a guide, pushing the branches away from walls and dead ends. It stops the robot from wasting time on paths that go nowhere.
But listen, this whole algorithmic cookbook idea, it's not just for building better bots. These hybrid recipes are popping up all over the place, in education, medicine, you name it.
Let's take online education. I mean, the dream here is to have a learning plan that's perfectly tailored to you, right? Not some one-size-fits-all course that doesn't really work for anyone. And the recipe for this is just fascinating. For the base, you use something called the a priori algorithm. Think of it like a data detective. It sifts through tons of student data to find hidden patterns in how people learn. Then you add a flavor algorithm called ant colony optimization, which is, literally inspired by how ants work together to find the fastest way to food. So the system finds the patterns, and then the ant algorithm uses those patterns to map out the most efficient, personalized learning path for each and every student. How cool is that?
And what about medicine? This is a really important one. These recipes are not about replacing doctors. Not at all. It's about giving them superpowered tools, helping them see things that were previously invisible.
Check out this combination. You have an AI using deep learning to scan, say, thousands of medical images. It can spot tiny, subtle patterns that even the most experienced human expert might miss. But and this is key, it doesn't just spit out a weird, unexplainable answer. It presents its findings using the same trusted methods and frameworks that doctors already know and use. It's the perfect partnership, the raw analytical power of the machine, guided by the wisdom and experience of a human expert.
So what's the big takeaway from all this? What's the secret ingredient in all of these recipes? Well, it's one word: synergy.
It's that classic idea of the whole being greater than the sum of its parts. And this synergy, it comes in a few key flavors. You can see here that about half the time, it's about pairing shiny new AI with a tried and true classical algorithm. But we also see AI being mixed with other AI, and maybe most importantly, AI being blended directly with human expertise.
Okay, so this naturally leads us to the question, what's next? What's cooking in the kitchen for the future? We're getting new algorithmic ingredients all the time. So what kinds of crazy new recipes are on the horizon?
Well, we're talking about way more sophisticated stuff. I mean, just imagine for a second, combining a generative AI, one that can come up with new ideas, with a reinforcement learning AI that learns from trial and error. Or what about embodied intelligence, where an AI learns not just from data sets, but from actually physically interacting with the world, kind of like how a toddler learns. The possibilities here are, they're pretty mind-bending.
And that really brings us to the main point. The hunt for that one single master algorithm that solves everything? That's over. It's old news. The future, it belongs to the chefs. It belongs to the problem solvers who know how to open up this algorithmic cookbook and creatively combine the right ingredients to solve a very specific problem.
So I'll leave you with this final thought. If I handed you this cookbook with all these incredible ingredients, what real-world problem would you cook up a recipe to solve? Thanks for joining us on The Explainer.